Okay, now we're going to try exercise 2. Maybe we'll do the first 4 questions of exercise 2. And here it is. They give you this cubic function and they give it to you in factored form. So it's easy to see the y-intercept there if you let x equal 0. And that's the first question, isn't it? You've got the questions in front of you, so I think you can just go step by step. And you can see that x is minus 3 and plus 3. Those are the x-intercepts. So that's the first question, and I got a computer to sketch it. That's question 4, I think, is to sketch the thing. Or maybe 3, 4. And there's your x-intercepts, and there's your y-intercept. It's 0 and minus 27. I think the next question asks about the turning points. This D here and this E here, where they turn. That's where the gradient or the derivative is equal to 0. So we take the derivative, we make it, there's the derivative, minus 3x squared plus 6x plus 9. We make it equal to 0. Divide everything by negative 3. You'll make this question much easier. It turns into x squared minus 2x minus 3. Then 2 brackets, and it's got to be 1 times minus 3 to give you minus 3, and they combine to equal minus 2x. So x equals minus 1 or x equals 3 are the x coordinates of the turning point. There's your minus 1 and there's your 3. All you do is take that minus 1 and put it back into the original equation, either one of those original functions, and you'll get the y value. For minus 1, it's minus 32, which makes sense, a little bit below minus 27, and 3 and 0. Hey, when it's squared like that, you know that it turns right there on the 3. That's the way it works. Okay, the next question actually asks you to sketch it. So you would have known that the shape of the thing has to be like this because it's a minus a in front of here. It's a negative there or there. You can see that a is less than 0. So there's the shape. You just put in the x-intercepts, the y-intercept, the turning points, and connect it. You need to label those points. So D you need to label with a minus 1 and minus 32. You need to put a minus 27 right there. Put a minus 3 there and a 3 there, and label that the x-axis and y-axis, and you'll be done. That's question 3. Now question 4 says, for which values of x is it concave down? When they say the word concave, you need the inflection point. So you take the derivative of the derivative, 2 times minus 3, 1 times 6, and you let it equal 0. And there you'll get the inflection point, where concavity changes. Well, you add 6x, divide by 6. Hey, x is 1. That's where concavity changes, at 1 and minus 16. We don't need the minus 16 because we know that if it's greater than 1, it's going to be concave down. If it's equal to 1, it's just going through the change. They asked, where is it concave down? That's when x is greater than 1. Well, there's the first. Let's do the other questions in another video.